All right, in this video, I am going to remind you of the trigonometric rules for solving sides and angles of a right triangle. So in order for us to solve missing sides and angles of a right triangle, we use right triangle trigonometry, which involves SOHCAHTOA. If you remember, the S stands for sine, the C stands for cosine, and the T stands for tangent. So if we look at this problem here where we have a blank triangle, if I'm trying to find sine of angle Y and cosine of angle Y and tangent of angle Y, we're going to put letters to these. So let's say that this is side A, B, and C. So for sine is opposite over hypotenuse. So if we look at angle Y, opposite of Y is A, divided by the hypotenuse, in this case is C. And then if we look at cosine is adjacent over hypotenuse. So adjacent to Y would be B, divided by the hypotenuse, which is C. And then tangent is opposite over adjacent. So opposite of that angle is A, divided by adjacent is B. And if it helps, what you can do is when you know what angle you're looking at, identify the fact that across from it is your opposite, across from the right angle is your hypotenuse, and therefore the piece that's left is your adjacent. Opposite, adjacent, and hypotenuse. Okay, so if we did the same thing, but now we look at Z, so now if we're looking at angle Z, then that means across from Z is your B, that's your opposite. Your hypotenuse is still your hypotenuse, C is still your hypotenuse, but in this case, your adjacent would be your little a in this case, opposite, adjacent, and hypotenuse. So if I did sine of angle Z, opposite of Z would be B, divided by the hypotenuse, which is C. Cosine of angle Z is adjacent over hypotenuse, so that would be A over C. And then finally, tangent is opposite over adjacent. So opposite of Z is B, adjacent is A. So that's an introduction to the trigonometric rules. Now, if we actually want to apply it and solve using sine, cosine, and tangent, let's look at our first example here. We're given angle 30. We're given side 7, which is opposite of angle 30. And then we're trying to find side X, which is adjacent to 30. So that, in this case, that would be opposite over adjacent. So if we use our SOHCAHTOA setup, opposite over adjacent is tangent. So that means I'm going to say tangent of the angle, which is 30 degrees, equals opposite is 7, divided by adjacent is X. So in this case, our denominator has our variable, so we need to multiply both sides by X to get the X out of the denominator. And then when I do that, I'm left with X times tangent of 30 degrees equals 7. So then to get X by itself, you just divide off the tangent of 30. So X equals 7 divided by tangent of 30 degrees. And then when you put that into your calculator or Desmos, make sure that you have it in degree form, 12.1. So then if we look at our second example, our second example wants us to find the equation set up for JK. Which equation should be used to find the length of JK? So I'm going to put an X here to represent that I don't know the length of JK. And so if I look here, I'm given angle 24. Your X is opposite of angle 24. The 28 is the hypotenuse since it's across from the right angle. So since it's opposite over hypotenuse, that would be using sine, because sine is opposite over hypotenuse. So we'd have sine of 24 degrees equals opposite over hypotenuse, which is 28. So then to solve for X in this case, you just multiply both sides by 28. And so therefore, this would be the equation setup. X is equal to 28 sine of 24 degrees. And you'd put it in the calculator to get the answer, but since it just wants the equation setup, it would just be 28 times sine of 24 degrees. So then, if we're trying to find an angle, in this case it says, what is the measure of angle J? We don't know that measurement. So if we look at what we're given, our 6 is the hypotenuse and the 4 is the adjacent. Since it's adjacent over hypotenuse, that means we'll use cosine. So I'd have cosine of the angle equals adjacent, which is 4, divided by the hypotenuse, which is 6. Anytime you're trying to solve for an angle in trigonometrics, you use the inverse. So we'd say x equals cosine inverse of 4 over 6. And then again, your calculator needs to be in degree mode, and you should get about 48 degrees. The last type of right triangle trigonometry is angle of elevation and depression problems, so basically applications. When we have problems like this, we're trying to figure out how to draw the right triangle that represents the given information. So here it says Billy is 74 inches tall. So if he's 74 inches tall, that would be a vertical length. That's how you measure your height. And it says his shadow is 70 inches long. Well, your shadow is on the ground. If you think about your shadow, it's always on the ground. So in this case, his shadow would be the horizontal length of 70 inches. And it says, what is the approximate angle of elevation of the sun? So when you're trying to find the angle of elevation is where you look horizontal and then up. So if we do that, the horizontal is his shadow. And if we look up to the top of his height, then that would be our angle of elevation. So the 74 would be opposite and the 70 would be your adjacent, which means in this case you're using tangent. Tangent of the angle equals opposite, which is 74, divided by adjacent, which is 70. And then when you're trying to solve for an angle, remember you take the inverse of it. So we'd say x equals tangent inverse of 74 divided by 70. So when you put that in the calculator, about 46.59, so about 47 degrees. And that's the introduction to right triangle trigonometry.